Hello. The biofuel I chose for this project was Cyanobacteria biofuel. To start off on some background information on cyanobacteria, it is a photosynthetic prokaryote, meaning it uses photosynthesis to create its own food. It is the most abundant photosynthetic organism on the Earth and accounts for about a quarter of all carbon fixation through marine ecosystems. It is found in many different environments, including almost all types of water, but most commonly fresh, brackish, and marine water. They can also be found in damp soil, on bare rock, or even sitting on the fur of sloths. Cyanobacterial biofuel offers a lot of pros, including minimal growth requirements, high and efficient photosynthesis rates, and wide availability. Cyanobacteria is cultivated in a few different ways. Natural light can be used through open cultivation using circular shallow ponds or raceways, or closed cultivation, which utilizes plastic or glass as an outdoor vessel to prevent contamination from other variables. Artificial light is also utilized through closed cultivation in photobioreactors, cemented tanks, shallow metal troughs, field methods, and polythene-lined pits. Here are a few pictures of these cultivation methods. The credit is given below. These show examples of photobioreactors. Biofuel is produced through photosynthesis. Cyanobacteria uses nothing but sunlight, carbon dioxide, and water to produce its energy storage components. This forms a feedstock that can be harvested. Transesterification is an organic chemical reaction in which the triglycerides found in the lipids of the prokaryotes transformed into diglycerides, which are then turned into monoglycerides. The monoglycerides are converted into esters and glycerol. The esters are turned into ethanol or methane gas, which allows the energy to be used as a form of biofuel. While cyanobacteria biofuel has been studied for over 30 years, it's still in research and development. It's not available as a fuel system at the moment because they're still doing research in genetic engineering and finding efficient ways to harvest the energy from the bacteria. This biofuel has a very low carbon footprint as it uses lots of carbon dioxide. Because it utilizes photosynthesis, it allows the bacteria to act as a carbon sink. Its rate of photosynthesis is twice as efficient as our current terrestrial plants used for biofuel. Additionally, cyanobacteria can be cultivated using wastewater. Traditional wastewater treatment methods contribute high amounts of carbon emissions, but cyanobacteria removes pollutants from contaminated water sources, providing clean water, while reducing the amount of freshwater resources needed for bacterial cultivation. Due to the fact it's still in development, there's not much known about the economic impact caused by this biofuel. However, if open systems are paired with wastewater cultivation and appropriate species that match local environments, it would greatly reduce the costs of the biofuel. Cyanobacteria biofuel has not been widely advertised or covered as much as other biofuels due to the fact it is still being researched and is not widely distributed. However, there have still been publications of scientific advancements and breakthroughs. I believe that this could be a great option for sustainable energy because it reduces the carbon footprint, has high efficiency of photosynthesis, and can be paired with wastewater treatment, as well as using native species in almost every environment, or having native species in almost every environment. My next steps would include investing more time and funding into research to optimize strains, building large-scale photobioreactors and cultivation ponds, building production facilities to meet demands, implementing supportive tax incentives and mandates, and most importantly, educating public about benefits and the importance of sustainable energy. These are my citations. Thank you to SlidesGo for the template. And thank you.